Hey, Mr. Harridan here. We're going to go over kinetic molecular theory of gases. This theory helps us understand why gases behave the way they do and gives us insight to their behavior as solids and liquids here as well. There's 5 basic postulates to this theory. Number 1, gases consist of molecules whose separation is much larger than the size of the molecules themselves, meaning the gas is mostly empty space. Particles in a gas move in straight line paths and in random directions. That's why you always saw me going zoom, zoom, if I could draw straight lines, zoom, like that. Particles in a gas collide frequently with the sides of the container, which is what causes pressure, and less frequently with each other. All collisions are elastic, meaning no energy is gained or lost in the collisions. It is only transferred from one molecule to another. Particles in a gas do not attract nor repel each other. They do not sense any intermolecular forces. In real gases they do, but we make this theory so that we can understand them better, to make it gases easier to understand, so we assume that they do not attract or repel one another. And the average kinetic energy of all the gas particles in the sample is proportional to the word I cannot say, temperature of the gas, meaning as the kinetic energy increases, the temperature increases. Okay. Movement of gases through Graham's law. If you have 2 different gases at the same temperature, they're moving at the same speed, right? Nope. They have the same temperature, which means they have the same kinetic energy. But remember, kinetic energy is 1/2 mass velocity squared, which is both influenced by the mass and the velocity. So what this means is you have 2 different gases at temperature. The gas with the greater molar mass is moving at a slower speed. The gas with the larger molar mass is moving at a slower speed, so the one with the less molar mass is traveling at a faster speed. This is what we call Graham's law. There is an equation for Graham's law. You will not need to solve any problems with it this year, but it is rate 1 over rate 2 equals the square root of molar mass 2 over molar mass 1. And rate here we're referring to speed or velocity. In physics they'll teach you the difference. They're not the same thing. Okay? Hey, you need to put that on the screen, Mr. Harridan, so they can actually see what you wrote down. That would be great. Okay? So, higher molar mass, slower speed. Lower molar mass, faster speed. Okay, let's look at our examples here. Okay? In scuba diving, a trimix is often used for gas tanks of the divers. Yeah, they used it on Oak Island, for instance, when they dove into 10X. This mixture contains nitrogen gas, helium gas, and oxygen gas. If it is assumed that all 3 gases are at the same temperature inside the tank, which of the gases molecules are moving at the greatest speed? What do you think? Hopefully you told me that helium has the lowest molar mass of these, so it is moving the fastest. Hopefully that's what you told me. Hopefully. HE, I mean, is helium, not he, just so you know. One inhales human gas, the voice goes up higher than normal, but one inhales sulfur hexafluoride gas, their voice gets lower than normal. If the two gases are stored both at room temperature, which gas molecules will be moving at the slower speed? What do you think? The slower speed is the higher molar mass. So we are going to pick SF6, sulfur hexafluoride. Okay, let's go on to page 3. Okay, let's go over the units for gas laws. Gas laws, you're going to have pretty much 4 units that you're looking at. P is pressure, V is volume, T is temperature, and amount, which is N. Okay, pressure units, we went over these in Unit 2. Atmospheres, torrs, kPa, psi, so on and so on. And you will still have to be able to convert through all those. Volumes, units would be liters, milliliters, centimeters cubed, so on. Temperature, there's only one choice for temperature for gases. Kelvins. Kelvins. Does not work with Celsius because Celsius has negative temperatures and you can't use those in proportions. N is the amount of substance, which is going to be the number of moles. Yeah, those things don't go away. Okay. Temperature must be in Kelvin. 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 Remember, you can convert from Celsius to Kelvin. K equals C plus 273. Pressure and volumes must be in the same unit. Sometimes you are going to have to convert your pressures over to the same unit using these conversion factors. And then you also have to watch out for STP. Yeah, you know me. Standard temperature and pressure. 0 atmospheres, not 0 atmospheres. That's not what it says, Mr. Harridan. 1 atmosphere and 0 degrees C. Yeah, you know me. Okay? Okay, we're going to stop there for this video here. So you guys are champions. The legend is out.